Good evening, ma'am. My name is Vaiman Kumari from Department of Civil Engineering. Today we will discuss about a part of in fluid mechanics is equation of motion. Introduction of equation of motion. Equation of motion describes the relation between an object position, velocity, and acceleration over time. They are fundamental in analyzing the dynamics of moving object in physics. Also, these equations are applicable in linear constant acceleration, providing predicative power and motion of analysis. Types of motion consider. Equations of motion typically assume linear uniform. They are used in scenarios such as free fall projectile motion and vehicle acceleration. The primary focus is on rectilinear straight line motion where acceleration remains constant. Next we will discuss the first equation of motion. The first equation relates initial velocity, acceleration and displacement over time. V is equal to plus at. Here V is the final velocity and also U is the initial velocity, A is the acceleration. Next one is the time. Is useful for calculating velocity of an object at any given the time during uniformly accelerated motion. Second equation of motion. The second equation contains displacement with initial velocity, acceleration and time. S is equal to ut plus frac 1 to at S represents the displacement covered during the motion. The equation helps determine the distance traveled after a specific time interval under constant acceleration. Next, we will discuss about third equation of motion. The third equation relates final velocity and initial velocity, acceleration and displacement. It allows calculation of all of the final velocity without needing the time variable. This is particularly useful when it is unknown or difficult to measure directly. Assumptions in equations of motion. The equations assume acceleration is constant over the time interval considered. They do not account for external forces like friction or air resistance unless account external resistance like friction or air unless explicitly included. These equations are valid only in idealized conditions and may need adjustments in real world applications. Next, we will discuss about applications of equations of motion. They are used in engineering to design vehicle acceleration profiles and safety features. In support science, they help analyze athletic movement and optimize performance. They are fundamental in physics, solve problems involving motion in various fields, including astronomy and robotics. Next, limitations of equations of motion. They are limited to linear motion with constant acceleration and do not handle variable acceleration. They do not directly apply to rotational or non-linear motion scenarios. Real-world factors such as friction, drag, and other forces require more advanced modeling beyond these equations. Summary of key concepts. The equation of motion provide a comprehensive framework for analyzing uniformly accelerated linear motion. Each equation is different sets of variables, allowing calculations of unknown quantities. Understanding their assumptions and limitations is essential for correction application in practical problems. Conclusion and further study. Mystery of equations of motion is crucial for understanding more complex dynamic and kinetic topics. further study includes extend these concepts to non-uniform acceleration and rotation motion. Practical applications often require integrating these equations in real-world factors for accurate modeling. Thank you, man.